Chapter 2-3, Calculus, Product and Quotient Rule. When we talk about product, what is that talking about? When you take the product of two things, what are you doing? We're multiplying. So we're going to multiply two functions together. There's a little rule we got to follow. And then quotient means the opposite of product, which is division. Okay, so we're going to do product and quotient today, multiplication and division of two functions. When we do the derivative, there's some rules. So as we take a look, our goals, first goal is know the product rule. This reads the derivative with respect to x of f of x times g of x, okay, is f of x times the derivative of g of x plus g of x times the derivative of f of x. Did you get that? No, that's pretty confusing. So we try to make this as painless as possible. And what we do is we say, okay, that first function that is being multiplied is the first function. We'll call that 1. And then the second function, we'll call that guy 2. Okay? So I got function 1 times function 2. Well, what we're going to do is we're going to take the first function. We're going to take that times the derivative of the second function. And then we're going to add the second function times the derivative of the first function. Or 1d2 plus 2d1. 1d2 plus 2d1. Okay, so you'll hear your calc teacher next year, Mr. Garris, saying that a lot. 1d2 plus 2d1. Okay, take the first times the derivative of the second plus the second times the derivative of the first. And that's how we do the product rule. Okay, so as I take a look, I have a function. I have this function is 2x squared minus 3x. That's my first function. And then this guy, 4x plus 5, is the second one. And again, when I have a quantity next to another quantity, that means multiplication. That means a product. Normally, we would FOIL that thing, right? Well, again, when we have a product, we do the product rule. So I'm going to go ahead and write this out. 1d2 plus 2d1. Okay. All right, so I take the first function. I take 2x squared minus 3x, and I'm going to take that times the derivative of the second. So I look at 4x plus 5. What's the derivative of 4x, and what's the derivative of 5? What's the derivative of 4x? 4. What's the derivative of 5? 0, so I don't need that. It's just 4 is the derivative of the second. Then I take plus the derivative, or I take the second one, which is 4x plus 5, times the derivative of the first. Okay, so I take a look. What's the derivative of 2x squared? 4x. What's the derivative of negative 3x? Just negative 3. So 1d2 plus 2d1. I take the first one times the derivative of the second plus the second times the derivative of the first. And now it's just algebra, right? So do a little algebra, do a little distributing. Whee! As I take a look, 4 times 2x squared we know is 8x squared. 4 times negative 3x is negative 12x. And then what do we have to do over here? We got to FOIL this thing. First outers, enters last. 4x times 4x is 16x squared. 4x times negative 3 is negative 12x. 5 times 4x is 20x. And 5 times negative 3 is negative 15. Final answer is just putting it all together. Simplifying. I've got an 8x squared and a 16x squared. So how many x squareds do you guys have? You got 24x squared. Then I have a negative 12x, a negative 12x, that's negative 24, and then plus 20x. So what's that? Negative 4x. And then last but not least, the negative 15. Okay, so again, that is what's called the product rule. Now, sometimes the product rule is all you got. Sometimes it's my only choice. But sometimes we want to work smarter, not harder, right? So if I give you this function again, you do not need to do the product rule. Let's think of another way that we could have done this that might have been a little easier. So here's my function again, same function. What's something else you want to try? What do you think? So don't do the product rule. We want to try something else. Can we rewrite this? How do I rewrite that? Starts with an F word. FOIL. Let's FOIL this thing. So 2x squared times 4x, that's 8x cubed. 2x squared times 5 is 10x squared. Negative 3x times 4x is negative 12x squared. And then negative 3x times 5 is negative 15x. So if I simplify the middle there, I get 8x cubed, 10x and negative 12x is negative 2x squared minus 15. Right? Now do the derivative. Do the power rule. Take your power and bring it down and multiply. What's the derivative of 8x cubed? 24x squared. What's the derivative of negative 2x squared? Negative 4x. What's the derivative of negative 15? There's negative 15x. Sorry, I forgot the x. Negative 15. Oop. Well, if I look, that's the exact same thing we did using the product rule. Okay? Now, from here on out, if you want to do the product rule, if you have something like that, you can. But isn't it a little easier just to FOIL, simplify it, and then do the power rule? Bring your powers down. Okay? So you can do the product rule if you're given this, but if you don't have to, why would you want to? Okay? So work smarter, not harder. If you see that you could FOIL something right away and then do the power rule, that's probably easier. Okay? All right. Do you guys have any questions? So for example, number 4, okay, I would probably just FOIL this thing out and then do the power rule instead of doing 1d2 plus 2d1. Okay, it takes a little bit more time doing that. All right, now sometimes you don't have a choice. So sometimes you do have to use the product rule. For example, example 2, I have 2x plus 5 times the sine of x. Okay, I know this is product rule because it's one function times another function. So this guy right here is my first function, and that's my second. And I'm going to go ahead and do h prime of x. I'm going to write out, again, 1d2 plus 2d1 every time when I do this rule. Okay, so I take a look. I got the first function. I've got 2x plus 5. And now from yesterday, we got to know what's the derivative of sine of x. So if you need to, look back at your notes on the second page of 2.2. What's the derivative of sine of x? Just cosine of x. And then plus 2d1, so I take the second function, sine of x. Okay, and I'm going to take that times the derivative of 2x plus 5. What's the derivative of 2x plus 5, y'all? Just 2. Derivative of 2x is 2. The derivative of 5 is 0. It's just 2. Okay, so far so good? So again, 1d2 plus 2d1. Do a little simplifying. We can go ahead and distribute, kind of like backwards. Okay, when you take cosine of x times 2x, the 2x goes in front. The x on the inside of cosine, you do not touch. That is on the inside of cosine. It's untouchable. You do not take 2x times that x and make it cosine of 2x squared. It's not how it works. Okay, you just keep it on the outside. And then cosine of x times 5 is just 5 cosine of x. Same thing, I got to take sine of x times 2. That is not sine of 2x. you multiply to the front, that is 2 sine of x, just like that. So final answer for your derivative is 2x cosine of x plus 5 cosine of x, and then plus 2 sine of x. That is, again, simplified all the way. All right, do you guys have any questions, y'all? Questions? All right. So as I take a look, we got some new trig functions and their derivatives. So this reads the derivative of tangent of x with respect to x is secant squared. And the derivative of secant is secant times tangent. The derivative of cotangent is the opposite of cosecant squared. And the derivative of cosecant is negative cosecant cotangent. Okay? Now, on the test, I would not worry about these. You might see these on some of the homework questions, but anything that's on the test might only involve sine and cosine. I did not include secants and cotangents and all that stuff. But if I did, they're right here on your 2-3 notes. Okay? All right, let's put this in action. I got example 3. I've got x squared and then times, there's a little dot there that's imaginary, you can't see it, times the secant of x. So again, I have x cubed. I think I might have said x squared. I have x cubed, that's my first function. And then I have secant of x, that's my second function. Okay, I have two things being multiplied together. So I have to use the product rule. There's no like shortcut. Okay, so I've got 1d2 plus 2d1. So I've got x cubed. And then I have the derivative of secant of x. So I go up here, the derivative of secant of x is secant of x tangent of x, just like that. And then plus 2 secant of x, derivative of the first. What's the derivative of x cubed? 3x squared. Bring the power down, that's why it's called power rule, and then deduct 1 to the power. Okay? Any questions so far? I would simplify this a little bit. Nothing you can do on the front, it's just x cubed, and then secant of x, tangent of x. But over here, you want to simplify. When you take this times the secant of x, really you just put it out in front. It's 3x squared secant of x. You do not take this x times 3x squared and make that 3x cubed. That's not how it works. This is inside of secant. You cannot touch it, manipulate it. It's off limits. Just put that number out in front of the trig function. Final answer. All right. If you had to do example 4, how would you do it? Huh? I would FOIL it first and then do the power rule, right? You could do 1d2 plus 2d1, but if you don't have to, why would you? Do we need to see example 4? We're good. All right, so you have seen three of these guys. Okay, 3 product rules. 1d2 plus 2d1, and it makes it pretty easy. Okay, well, guess what? Last page of notes. Oh my gosh. And now I leave you with what's called the quotient rule. So I'm going to have 2 functions. I'm going to have a fraction, and on the top is the first function, h of x, and on the bottom is L of x. Okay? So I want to take the derivative of this function. To do that, I got to take the one on the bottom times the derivative on top, and then minus the one on top minus times the derivative of the bottom over the bottom one squared. And you're like, what? Okay, well, we have a little saying here. Okay, so this one is the high one. And this one is the low one. That's why I'm using H and L's. Okay, so to do the derivative of a quotient, we're going to take the low one times the derivative of the high one minus the high one times the derivative of the low one, all over low, low, or low squared. So the way I say this is low d high minus high d low over low, 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 no. Low d high minus high d low over low, low, or low squared. Low d high minus high d low over low, low, or low squared. Okay? So that takes something that looks awfully confusing and kind of makes it a little easier, and it's kind of catchy. Low d high minus high d low over low, low. Okay? So as I take a look, this is going to be my low one. It's on the bottom. And this is going to be my high one. Okay? And I want to find the derivative of g of x. So I'm going to take low d high minus high. I always abbreviate usually. So high d low over low, low, or low squared. So this looks super, super scary. But if you follow low d high minus high d low, super, super easy. So take the low one. In this case, x minus 2. And then I'm going to take the derivative of the high one. What's the derivative of x plus 2? Just 1. Derivative of x is 1, derivative of 2 is 0. Any questions on how I found that derivative? We okay. Minus the high one, x plus 2. So put parentheses around that. Times the derivative of the low one. What's the derivative of x minus 2? Just 1. And then that's all over the low one times itself, which is just low squared. And we do a little simplifying on top. You might have to FOIL, you might have to distribute, what have you. Okay? So if I take x minus 2 times 1, we know that's x minus 2. I've got x plus 2 times 1 and then times the negative, so I'm going to distribute the negative. So I get negative x, negative 2, and that's all over x minus 2 squared. Simplify. What happens on top? The x's cancel, x minus x cancel. I get negative 2 minus 2 is negative 4 all over x minus 2 squared. So that is the derivative of that function using the quotient rule. Unfortunately, there's no like shortcut. This one, you have to use the quotient rule. There's no other way to do it. Okay? Again, this is my formula that allows me to find the slope anywhere on this function. Any x value I want to plug in. All right, do you guys have any questions? So let's try it again. It's always nice to see this thing at least 3 times. So I got my low one, and I got the high one. Okay, so what I usually do, if I want y prime, I'll usually do low as an L, and then d high, dh, minus the high one, I just do h, and then d low, just for short. And then low squared, or L squared on the bottom. Low d high minus high d low, for short. So I take the low one. I've got 3x minus 7 times the derivative of the high one. What's the derivative of 5x minus 2? 5. Minus the high one, which is 5x minus 2. And then times dl, the derivative of the low one. What's the derivative of 3x minus 7? 3. And that's all over the low one squared. 3x minus 7 squared. Low d high minus high d low over low low, or low squared. Any questions on the setup so far? I hope we're taking notes. Okay? So we do a little simplifying on top. I'm going to go ahead and distribute the 5 to each one. So 5 times 3x we know is 15x. 5 times negative 7 is negative 35. Okay, now I've got to distribute this 3 and the negative. So what I'll do with this, I'll make this a plus and make this a negative 3. And that way I'm distributing both the negative and the 3 at the same time. I've got to subtract that quantity. So negative 3 times 5x is negative 15x. Negative 3 times negative 2 is 6. And then we simplify the top. 15x and negative 15x are going to cancel. And what's negative 35 plus 6? Negative 20 what? 29? You guys okay with that? And that leaves me with 3x minus 7 quantity squared. So final answer, negative 29 over 3x minus 7, and then quantity squared. Woo! That's not so bad, right? Any questions? Calculus, baby. When would I ever use calculus? Never. No. When would you use calculus? What's one of the biggest applications? Real physics class, right? Physics is the change in our environment, the change in the position. That's when you're changing your position, you're moving. The change of your position is a derivative, which is velocity. The change in speed, that's the derivative of speed. That is acceleration. Oh my gosh. Physics, baby. When would I use this? Oh man, you want to be an engineer? This is when you'd use this stuff. Here we go. All right. Last but not least, want to do number 7. I got h of x equals sine of x over cosine. I'm going to do this one real quick. This is my high one. This is the low one. So again, I want to do h prime of x. I want to do low, d high, minus high, d low, over low squared. Low d high minus high d low over low squared. So as I set this up, I take the low one, which is the cosine of x, and then times the derivative of the high one. So from yesterday, what's the derivative of sine of x again? Cosine of x. Okay, if we look back at our notes from yesterday, derivative of sine of x is cosine, derivative of cosine is negative sine. Okay, that's from our 2 notes. So now I do minus the high one, minus the sine of x, and then times the derivative of the low one. What's the derivative of cosine of x? Negative sine of x. So far, so good. And then over low squared, cosine squared. Cosine of x times cosine of x is cosine squared of x. Okay, so we simplify the top. Any questions on the setup? So we simplify the top. Cosine times cosine we know is cosine squared. Negative sine of x times negative sine of x. Negative times the negative is a positive. Sine times sine, sine squared. Oh, Pythagorean identities. Here we go. Pythagorean identities, 7-4 stuff. What's cosine squared plus sine squared? You guys remember what this represents? That equals what? 1, right. So we get 1 over cosine squared. And now, what's 1 over cosine? Who's his buddy? Secant, remember inverses, right? So this is, cosine's buddy is secant, so if I have 1 over cosine squared, this is Secant squared. Final answer would be secant. Okay? Now remember when I said work smarter, not harder, right? We did a lot of work here. The original function was sine of x over cosine of x. Well, we should know what sine of x over cosine of x is. What is sine over cosine? That's tangent. And we just talked about, on the front page, what's the derivative of tangent? Secant squared, right? So, if you do have some trig functions, and you can simplify what they're giving you, you can use that, and then use those little trig identities that I just gave you, the derivatives of those trig functions, to make your life a little easier instead of going through all of the low d high minus high d low over low low. So again, sine over cosine is tangent, and the derivative of tangent is secant squared. Okay? Either way works. But this one we had to do the quotient rule. Then we had to use some Pythagorean identities, and then we had to use the inverse of cosine and apply that. Okay? All right, ladies and gentlemen.